My name is Andrew Romans, and this is the Project 3 Connect R for artificial intelligence. First off, I thought I would start by kind of going through my code and explaining or showing how I made my artificial intelligence functional for the opponent, meaning the MinMax algorithm, my heuristic function, how I got everything working. Basically, for my min-max algorithm, I used a generic tree structure, data structure. Have a node. I'm not going to go too in depth into it, but I have a node class that consists of the parent node, a list of its children, the data of that node, its heuristic score, and its index. And then the tree class itself consists of the root node, the current node that it is pointing at, and then the recent node, which was the node that it was recently pointing at. Um, and then functions to cycle through the depth and the children. Um, to actually create the game board, I had a class of grid pieces that contains a enumerated state that is either empty, filled with a red piece, or filled with a black piece. And each piece keeps track of the size of its screen height and width, and other pieces around it, and makes sure that no matter how many pieces there are on the screen, and no matter how many there, I guess how many there are, it will always resize itself down to fit the screen. So the more pieces you have, obviously, the smaller the board is going to be, but it will fit on the screen for sure. As well as it contains logic that determines whether or not a mouse has been clicked in its position. If it has, it finds the column of which that grid piece is in within the game board itself, and then that way it detects and knows where the player is trying to place a piece down. Um, the game one class itself, this is where we set whether the how many columns and how many rows we want, and then the connect amount, how many our win state. Um, our initialization takes in and creates a new connect class, which is here, which we'll get into just a second, as where most of the magic happens. From here, we determine whether or not we want the opponent or the player to start, or if we want a one-player game or a two-player game. One player being you play against the AI, two-player game you play against another human being. Okay, and now let's get into the magic. So first off, the connect class contains three enumerated types. The first one being the turn itself, whether it's the opponent or the player's turn, whether the game has been won or whether the game has been tied. From there, we have the game type, so if it's a one-player game or a two-player game. And then we have whether or not which player won. So if it's no player, it's a game tie. If it's player one, or it's player two, since game has been won. Once it has been called and initialized and all the values has been set, we prepare the game grid, which sets out multiple sections of those pieces to actually create what our actual board itself, and sizes it properly. And now we are ready to play the game. Um, Starts off an update, which every cycle checks for a win state, make sure that we can't move forward if the game's already been won. If it is a player's turn, the player will then pick which grid piece or column it wants to choose to place a piece in, and then moves that piece down, which I have this function here, which detects to see if there's any other pieces within that column. That way it actually functions like a normal Connect 4 game would and doesn't overlap pieces, and then changes over the turn to the opponent. Um, Now, if you are playing versus an AI in game type 1, it will start the min-max function. Every time the opponent turns, it creates a new tree with a copied version of the current grid as the root node. Um, from there, it creates a thread, a timer thread, that calls in the temp that passes in the temp decision tree. which you can see here, which then creates another thread that calls the MinMax call thread here, which is what starts the MinMax function. From here, it takes in the tree itself, the current depth of which we're at within the tree, how far down we want to go within the tree, and whether or not we are looking for a max or a min. The min-max function I created is using recursion. It starts off by looking at either the opponent or the player pieces. It will then create a child from the root, and it will keep going down and cycling through that until it has reached the furthest depth, the target depth. Once it has reached the target depth, it will go through each one of those target depth children and pass in its heuristic function as its score. The heuristic function is here. The way that I am scoring my grid is I'm checking for the R win state for either the player or the AI. If neither of these are triggered, then it looks for R minus 1 and R minus 2 for both the AI and the player, adds them together, and then subtracts them. And then whoever is the closest to winning for the player would be in the negatives, closest to winning for the AI would be in the positives. Based off of what that evaluation is, it returns a board score within decimal point value to its uh, proper value. It then recursive and returns out of it and continues doing that until the root node has the chosen heuristic value through the min-max functions. Always keeping track of min and max, which is always changed every time it goes increased or decreased. From there, once it has received the heuristic function or the heuristic value of which to go down, it will determine whether or not there are multiple values within that root node's children that have the same heuristic score. If there isn't, it'll choose the proper action and then cipher that action, which is just determining what grid piece is new from the original grid that we have that the player is looking at. Otherwise, if there's multiple values with the same heuristic score, it will then run this function here, or this method, these statements that determine which is the best action to make um, of those same heuristic scored nodes. And then from there, that is constantly looped until either a player has tied, a player has won, or the player has left the game. And other than that, that's about it. That's how it functions. So we'll start off by showing you a default 7x6x4. Sorry. That way we can see the original values working and the AI working. So um, it determines or shows you who is winning or whose turn it is. Same for the two-player game. It will say player one's turn, player two's turn. I'm just going to go ahead and place one here. The further down it goes, the longer it goes, but the more of it cuts out based off of the multi-threading. So I'll to go here. The AI shouldn't like that. It does its thing. See if I can get the AI to win here. Place down here, it's going to try to win here. Place one there. Should go here. And then we'll just let it win to show the win state. So yeah, so it had two ways of winning. I gave it two ways. I put one here, gave it here, or it could have went there. Either one worked. So it then notes that the opponent won, and then the restart, all you have to do is press enter, and the game should restart. But for now, we will change the value to 17 by 16 by 6. And one thing that I did notice that is the further down in depth you go and the bigger the grid gets, the more your computer runs out of memory. um, so in order to have a bigger grid, I actually have to make the search a little bit less of a search, but works the same nonetheless, just a little bit less accurate. Um, so if I was to try to get a connection of 6 here, she's about to try to get. He has one more to win. So block that. So if I have 4 here, that's 5. He should not like that. Give me the value to win, or I won. So, and then enter to restart, as I showed before. And that's my Connect R project. It's not 100%. I could definitely find better or alternative ways, I'm sure, of adjusting my heuristic function. I did notice that the AI likes to spawn to the left or the right furthest section of the grid. But knowing Connect R or Connect 4 itself spawning in the middle actually gives you the better chance. So obviously there's something that I'm doing differently that is making the AI think that that is the best option. Um, but for what I have here, I feel very confident and very happy with the outcome that I've worked for because it definitely was a mind was a brain tweezer brain teaser for me. But I definitely enjoyed the project. So thank you very much.